All right, so today we are going to solve 3x3 systems, meaning 3 equations, 3 variables. And so in order to do that, we need to review how to solve 2x2 systems, 2 equations, 2 variables. And so specifically today we're using substitution. We'll get to elimination next time. And so for substitution, the first thing you need to do is pick an equation to isolate a variable. And so you're looking for a coefficient of 1 so that you won't have to divide by a number. And so here, this would be the easiest variable to solve for, because here I would have to divide by a 3, here I'd be dividing by -4. And so I'm going to pick equation 2, the variable x. And so from equation 2, if I solve for x, I would have to subtract 14y from both sides. And so my new equation would be x equals 10 minus 14y. Then our remaining equation that we haven't used, equation 1, we are going to substitute the x variable. And so here, x equals 10 minus 14y, we replace the x here. And so I would rewrite the entire equation without the x, and then fill it in with what x is equal to. Now we have an equation that just has y, and so we can solve by distributing. Combining like terms. Isolating the y term. Isolating the y variable. And so -23 over -46 is 1/2. Okay, and so once you have the y, you can substitute that back in over here. So x equals 10 minus 14y, which we know is 1/2. Oh, that's an ugly 2. 14 times 1/2 is 7. So x equals 10 minus 7, which is 3. And so our final solution here is 3, 1/2. We follow these same steps when we have more variables. And so here's your list of steps. You pick an equation, pick a variable, use that equation to isolate that variable, substitute that variable, and then you'll see you're going to be left with a 2x2 system. So here's the list of steps. I'm going to go through them on this example. And so now we have 3 equations. Pick an equation and pick a variable to solve for, just like we did on the warm-up. And so here I'm going to pick equation 1, variable x, because this variable doesn't have anything I'm going to have to divide by in front of it. And so if I solve for x, I move everything else to the other side. So it would become positive 6y, positive 2z minus 8, moving these two to the other side. My biggest suggestion is do your 2's with a loop, z's with the bar. Otherwise, that's going to turn into a vague 22, and you're going to get really confused. I see that mistake all the time. So 2's with a loop, z's with a bar. No matter what your handwriting's like, start doing your 2's with a loop, z's with the bar. Okay, and so after you've picked an equation and isolated a variable in that equation, take your remaining 2 equations. So we have not used equations 2 and 3. And we are going to substitute the x variable in all of these equations with this expression. And so copy down the equations without the x. So equation 2 would be negative x plus, I'm going to need more room than that, negative x plus 5y plus 3z equals 2. And then equation 3 says 3x minus 2y minus 4z equals 18. Now we are ready to substitute this expression. 6y plus 2z minus 8, 6y plus 2z minus 8. Okay, and so now you want to simplify both sides as much as possible. And so the first thing is distribute this negative, which is technically a -1. So negative 6y minus 2z plus 8 plus 5y plus 3z equals 2. Combine your like terms. So I've got a negative 6y. Let me use a different color. Negative 6y plus 5y is negative 1y. Negative 2z plus 3z is 1z. And then move your constant to the other side. So equals negative 6. So I call this simplified equation, equation 4. We're going to do the same thing over here to get equation 5. Distribute your 3. Combine your like terms. 18y minus 2y is 16y. Six z minus 4z is 2z. And move your constant to the other side. Okay, and then before you box this and call it equation 5, if there is a common factor in all three places, like a 2, go ahead and divide the entire equation by that number, just to keep the number smaller since we don't have a calculator. And so 8y plus z equals 21 would be a nicer equation to work with. And so there's your equation 5. And so from there, you're going to take equation 4 and 5, and now you have a new 2x2 system. And you can solve that 2x2 system honestly any way you want. Elimination, substitution. I'm going to stick with, actually, I'm going to go to elimination. No, I'm going to stick with substitution. So I'm going to isolate a variable. So I'm going to use equation 1 and isolate the z variable. So z equals y minus 6. Just add y to the other side. And then we can take the second equation, 8y plus z equals 21. Substitute that here. I'm out of room. And so 8y, these parentheses have no purpose. So we can go ahead and combine our like terms, which is 9y. Move the 6 to the other side by adding 6. Divide by 9. And I have y equals 3. Okay, so once you have one of your variables, you can pick. Do I have another color? Ooh, let's see what that looks like. You're going to go back to one of your original equation 4 or equation 5 and substitute that y back in to get your z. Okay, and so I'm going to use equation 5 just because it's closer. 8y plus z equals 21. And we know that y is 3 now. And so 24 plus z equals 21. And so z equals -3. Okay. And so I know y and I know z. So now we can go all the way back to the beginning and get our x value. And so x equals 6y plus 2z, minus 8. And we know that y is 3, and we know z is -3. And so x equals 18 minus 6 minus 8. 18 minus 6 is 12. Minus 8 is 4. And so now we have all 3 variables, and write them in alphabetical order just like we do x comma y. We're going to do x comma y comma z as our final answer. So let's use this color. Solution. X is 4, y is 3, and z is -3.